All right, boys and girls, welcome back to the drive-thru. Special shout out to Alex. Thanks for your patience, all your hard work in math. Good luck, and have fun in Florida on your trip. Jealous, but proud of you. Okay? We're going to go over this is maybe one of the most important things you can learn in Algebra 1. It's important for me to understand that you cannot solve that equation because there's infinitely many points that work. Similarly, you cannot solve that equation because there are infinitely many points that work. But there is only one solution to both of those equations, and that's what you're doing. Now, there is an exception. If they're the same equation, then there's infinite solutions, but you're not there yet, okay? So, we're going to start. I'm just going to recopy the equations down. This equal sign is very powerful. I don't think we do enough to emphasize the power of the equal sign. Anytime something's equal, you can take something else out and put that in. So my strategy is anywhere I see a y, I'm going to put in an x plus 5. Okay? So 2x plus x plus 5. And then I got to write down the rest of the equation. Now, what number is in front of this x? It's a 1. So what is 2x plus 1x? So don't start subtracting and just combine like terms. All right, now I want to get the letters by itself, so I subtract 5 from both sides. You get 3x is negative 6. Divide each side by 3. And you get x is negative 2. Now, that's not the answer to the question. It's part of the answer. X is negative 2. Well, what's y? Well, y is x plus 5. Once again, the power of the equal sign. So anywhere I have an x, I'm now just going to put in a negative 2. So y, sorry about that, is negative 2 plus 5. So y is negative 3. Sorry, y is 3. And x is negative 2. If you go back to the original equations, both of those points should work in both of those equations. They're the only ones that work. If you want to think about it graphically, both of these things are lines. It's the point where those two lines intersect. All of these are the same thing, okay? So let's do the second one now. And anywhere we have an x, I'm going to put in y minus 1. This one's a little harder because it involves distributing. But just take it one step at a time. What is x? So I'm going to put it in parentheses. There used to be an x there. X is equal to y minus 1, so now I've taken it out. The advantage is, can I solve this red equation? Yes, I can. It's only got one variable. It's only got one solution. Okay? So you get 5y minus 5 plus 2y equals 9. This is a spot where a lot of people make a mistake. They start trying to move stuff. Just combine like terms. So that's 7y minus 5 is 9. Next step, add 5. You get 7y equals 14. This is how I start to think, oh, I'm doing this right. Because you divide each side by 7, and you get y equals 2. Now I go up. X equals y minus 1. So, worst. So x equals 2 minus 1. So x equals 1. Y equals 2. Don't be like caught off guard if you see people answering this question like this. That works too. It is a point. Because remember, it's where the two lines intersect. Okay? Scuba for life. Boom!